Okay, this video is associated with Unit 5, Activity 4, which is talking about the volume and surface area of prisms. In the course content, the two prisms we've discussed are the rectangular or square-based prism and the cylinder, which has a circular base. And we discovered that the volume of the prism, which is a measure of capacity or how much space I have inside the shape, with a three-dimensional measure, is just the area of the base. So here I would take the area of that rectangle, here I would take the area of that circle, and then to find the volume, I just multiply by how many times I need to stack the base, or multiply by the height. So in this case, I would find the area of the base by doing width times length, and then multiply by the height of the prism. In the case of the circle, well, the area of the base is going to be pi r squared, and then I'd multiply by the height to find the volume of the cylinder. So it's always area of the base times height. And what I want to say in this video is that's true for other types of prism. So a prism is any shape that has rectangular walls. So for example, like a Toblerone bar or triangular prism is going to be the same thing. I can find the area of this triangle and then multiply by the height or the lengths of those rectangular walls. Could even be a hexagon, a pentagon, an octagon, whatever you want. So this is a hexagon. It's got 6 sides. I'm not a great artist, but I'll do my best. I could draw a hexagonal prism. And again, I just want to find the area of the base and then multiply by the height. So that volume formula is true for any type of prism, not just the two that we sort of dealt with in the course content. Why is a cylinder a type of prism? Well, 2 ways to think about that. One way is that a circular is sort of like a polygon with infinite sides. You kind of think about a circular as a circle as having infinite sides on the bottom. So it has infinite walls. Another way to think about it is that it's got exactly one side and it has one rectangular wall. So here I've made a paper cylinder. Got a circle at the top and the bottom, you can see that. And then if I unfold the sides, it does become a rectangle. So that rectangle's got the height of the cylinder here, and then it's got the circumference of that circle on the top. So when I unfold the circumference of the circle, it becomes the length of that rectangle. So I don't recommend you use this at home, but if you cut up a Coke can, that big middle piece would become a rectangular wall. So that's why we treat cylinders just like we treat any other type of prism. The other concept I wanted to discuss in this video is in the course content, we were mostly solving for either surface area or volume. We can also work the other way. If I know the surface area of the volume, I can solve for other missing variables. So let's take an example of a cylinder where I know that it has a radius of, let's say, r equals 5 centimeters, and I want to try to find out, well, what's the height? How tall is that cylinder? And I know that the surface area is 500 centimeters squared. So the formula for surface area of a cylinder, and of course you can use your formula sheet. I don't expect you to memorize things for this course. Math is not about memorizing, but we could deduce it. A cylinder has got 2 circles, so it's going to be 2 times the area of a circle, which is pi r squared. And then it's got that rectangular wall we just talked about. That rectangular wall has a length that is equal to the circle's circumference. Remember that circumference is 2 pi r, right? Pi times diameter, or pi times 2 times radius. And then multiplied by the height, because that's going to be the width of that kind of rectangle, if you can imagine us unfolding the cylinder. So there's my formula for surface area. Let's plug in what we know. Surface area equals 500. And every time I see radius, I can replace it with what we know, that the radius is 5 centimeters. Pi, let's just leave as pi. I could replace it as 3.14, but I like to do that at the end. We can talk about that more in a second. I like to try to keep the answer exact, so I like to just leave pi in. We know it's a number. So I know that 5 squared is 25. 25 times 2 is 50, so I have 50 pi. That's the area of my 2 circles. And the area of this rectangle is going to be 2 times 5, 10 pi, times h. So now I've got an algebraic equation that I want to solve for h. I want to get h by itself. So I'm going to move this 50 pi onto the left side, so it becomes a negative 50 pi. So that's going to equal 10 pi times h. So to get h by itself, I have to divide both sides by 10 pi. It will cancel out on the right side. On the left side, I'm left with 500 minus 50 pi divided by 10 pi. And we call this an exact form of the answer because I have the exact value of pi. I'm using the Greek letter pi to represent it. Usually, we leave our answers in this course in approximate form. So I'm going to use 3.14 in my calculator for pi. I usually only do that in the last step so that I avoid rounding and decimals and things like that as I'm working through a problem. So I like to get the exact form, express my answer in terms of pi, and then we can find the exact answer. I'll do the numerator first, 500 minus 50 pi. And I'm going to divide it by 10 times pi. I'm using the pi button, but if you prefer to use 3.14 in your calculator, that's fine as well. You might have to play with your calculator to see how this all works. So I've discovered that the height of this cylinder is 10.91, and the units of height is just the length, so centimeters. The reason I wanted to go over this is just to show you that we don't always just solve for surface area and volume. We can use kind of our algebraic tools to rearrange the equations to solve for height or to solve for radius or width or whatever the question requires. So that's all I wanted to discuss in this video. Again, if you have any questions, please send me an email or, as always, leave a comment on the YouTube. That's all for now. Thanks for watching.